I welcome you for this presentation. In this presentation, we are going to discuss about one of the classification techniques, that is decision tree. So this is the overview of this presentation, that is introduction about the classification, that is what are the learning process available in classification. Then classification is two-step process, then algorithm for decision tree induction, a brief overview of entropy, then attribute selection measures like information gain, that is iterative dichotomizer, that is ID3, then Gini index C4.5, then gain ratio, classification and regression trees, that is CART. Then I have given some two practice problems, then summary of this presentation. So here the classification process, that is this decision tree is one of the classification process. Classification means it is a mainly supervised learning, not mainly, always it is a supervised learning technique only. Supervised learning technique means from the name itself we have to know that supervised, some supervision is available. That is supervision in the sense some class labels are available. So based on the class labels, we are performing some learning process and we are constructing a model from the learned data. So here supervision in the sense here the training data is available. In all the classification problems we are having the training as well as the testing data. Training data is used to train the model, that is make the model to learn something, and we are constructing a model from the learned data. Then how we are performing learning means with respect to the class labels. So the output of each and every record in the training data is known. So based on the class label only we are performing the training or learning process and we are constructing a model. So after performing the training process and constructing a model, what we want to do is, if any unknown data comes in, then we can test the model using some test data. So generally in the data set we are having training data as well as testing data or test data. So suppose in your data set it is not specified as training data and testing data, means you have to divide the given data into two parts. One is the training data and another one is the test data. Generally, the ratio used for separating or splitting this available data into training data and testing data are generally 70:30 or 80:20. In this sense only, we have to divide the given data into training data set as well as testing data set. So while doing the project, you have to take care of this. Suppose in the data set, if it is not mentioned as training as well as testing, you have to split the given data into 70% of training and 30% of testing. Otherwise 80% of training and 20% of testing. Then only you can perform the training or learning process. So here supervision means the training data, that is observations or measurements are accompanied by labels. Class labels are available. That is the supervisor here, indicating the class of the observations. Here class labels or target or actual output. The meaning is the output of the given record. That is the meaning. That is called as the class label. Say for example, if we are taking COVID-19 data, that is whether the person is having COVID-19 or not, or normal. Likewise, the class label is there. So two classes are there. Disease is present or disease absent. Suppose if you are taking any network traffic data, then the attack is there or it is a normal data. Likewise, different classes are there. Not only two classes, multiple classes are also there in the data set. So suppose if the data is having the class labels, then we can use the data for classification purpose. That is supervised learning. Unsupervised learning means here there is no supervision, that is class labels are not available. So here the class labels of training data is unknown. That is given a set of measurements, observations, etc. with the aim of establishing the existence of classes or clusters in the data. So generally unsupervised learning techniques are clustering. So the output of the class label is not known for the given training data. So while discussing clustering, it will be clear if the class labels are not known, how we have to cluster the data. For that, what methodology we are going to apply, that we will be discussing in detail. So now today's presentation is about classification, one of the classification techniques. So always for all the training records, we know the class labels. So after performing the training process, we have to construct a model. That is, here we have to construct a decision tree, and based on the decision tree, whatever we have constructed, based on the decision tree, if any unknown input is given to the decision tree will classify the given data into any one of the classes. That is the classification problem, and we are going to discuss about decision tree. So next is classification versus numeric prediction. That is, classification means it predicts the categorical class labels, that is discrete or nominal, and it classifies the data, that is constructs a model based on the training set and the values, that is the class labels in the classifying attribute, and uses it in classifying new data. So always we may have a doubt that what is the difference between classification and prediction, because both we are calling it as some classification type of thing only we are calling. So what is the difference? Sometimes if you are using, we apply the classification technique, but we used to tell we are detecting whether some malicious activities happen in the network or not, or we are detecting or predicting the disease. Likewise, we used to have the terms like prediction or detection, so classification. So what is the difference between these two? So mainly classification means it predicts, here also it predicts the categorical class labels, that is mostly here discrete or nominal data for classification, and for numeric prediction the models are continuous valued function. That is the difference between classification and numeric prediction. But in most of the research papers it is given, they may use the classification technique, but they have given the title as prediction of, or predicting the, or detecting or detection of. Likewise, they used to have the terms, but there is a slight difference between numeric prediction and classification. So mainly the classification we use for the discrete or nominal data class labels. The numeric prediction we generally use for that is we are models the continuous valued function, that is it predicts unknown or missing values. Here mainly it predicts weather prediction, weather forecasting, all those things we are predicting. So here but both the terms are used in either cases also. While reading the research papers and all, in either cases they use the term prediction, classification, detection, all those things. So now no need to confuse too much. So some of the applications for this classification and numeric prediction include credit card loan approval, that is if a credit or loan is approved or not. So we can classify. So how we are classifying it? Based on some historical data, that is earlier financial transactions data. So based on some criteria, so based on the historical data, we are constructing a model, and we are telling that any new input is coming or any new customer is applying for credit or loan, then based on the previous history of data, we used to classify it as the loan may be approved or may not be approved. In such way, in such a manner we can decide based on the old data or the model constructed using the training data. Next, we can use this classification or prediction in this medical diagnosis, that is if a heart disease is present or not, if COVID-19 is present or not, if tumor is cancerous or benign. Likewise, we can use this classification for medical diagnosis as well. Then we can use it for fraud detection, that is fraud detection means if a transaction is a fraudulent transaction or not. For in such cases also we can use this classification technique. Next is web page category, that is which category this web page belongs. Likewise, we can classify it. These are some of the example applications. There are n number of applications available. These are some example for the classification problems. So in the classification, we are having two steps. One is the model construction process and another is the model usage process. So using the training data, we have to train a model and we have to construct a model. That is what the model will do is it just learn the data. That is from the existing data, you with the help of the class labels, this model will learn the available data and a final model is constructed. Here a final decision tree is constructed. So using the decision tree, then model usage, coming to the model usage. So in the training phase, we are constructing a model and in the test phase, we are using that model. So here in any classification approach or process, we are having two steps. One is the training phase as well as testing phase. So in the training phase, we are constructing a model and in the testing phase, we are using the constructed model. So in the model construction, it is describing a set of predetermined classes. That is, each tuple or sample is assumed to belong to a predefined class as determined by the class label attribute. The set of tuples used for model construction is called as training set. And generally, in the given data, the last column only specifies the class label generally. And the model is represented as classification rules, then decision trees or mathematical formulae. So the model construction, we are talking about the model construction. So the model may be represented as any way, that is classification rules. We can use it as a classification rules or decision trees or some formulae also. So using that constructed model, then we are classifying the data. So how we are classifying the data? So in the model usage, we are classifying future or unknown objects. So for the test data, the class in some data set, the class labels are available. The class labels are available. Why the class labels are given means because we want to find out the accuracy of the model what we have constructed. For that only we are having the class labels in the test data also. So finally, after constructing a model, we are testing the model and we are telling that my model is producing or I obtained this much percentage, 90% of accuracy using this constructed model. Likewise, we are climbing. So why we are climbing like that means, so with respect to the test data also we have tested the model. So some unknown data are coming in. For those unknown data, we don't know the class label. Some new data are coming in. At that time, we can check with the model and we can classify whether the given unknown data belongs to a particular class or not. So for that, we have to estimate the accuracy of the model. So accuracy, you know, there is a formula to find out the accuracy. The known label of test sample is compared with the classified result from the model. That is, the accuracy rate is the percentage of test set samples that are correctly classified by the model, and the test set is independent of training set, otherwise overfitting. So always the test set is independent of the training set. If it is not independent, it is dependent means what happens means the results produced or overfitting results only we will be getting. That means already the model is trained with that particular data, so definitely this model will be producing good results. So mostly we can't get the exact result, overfitting of the model only we are getting in. So always we have to use an independent test set, no merging of the training data with the test set. Then if the accuracy is acceptable, that is what do you mean by acceptable? That is some percentage. In some papers and all, they used to tell that I got only 70%. But if 70% only the model is accurate, then whoever will trust, suppose if you are constructing a medical diagnosis system. So suppose if your model is only giving 70% accuracy, then how we can play with the lives of people? It is not that much, no. So we are paying so much for the life of a people. So always the critical applications and all must give at the most maximum accuracy, that is above 95-99% of accuracy we used to expect. Suppose if your model is not providing that much accuracy, then we have to perform or give some improvement in the model in order to improve the accuracy of the constructed model. So if for some critical applications and all, we need high accuracy, then only we can use that model in the real time scenario. Otherwise it can't be used in the real time scenario. So if the test set is used to select models, it is called as validation test set. So in addition to the training as well as test set, there are one more set called validation test. So when the validation set is used, in some cases the validation set is used, but this training and testing set are very, very important. Validation test when we are using means if the test set is used to select models. So if you want to validate the model, in such cases we can have the validation set also. That is a test set used to validate the model. So this is the example for the model construction. That is, here we are having the training data. So here we are having a training data. This is the training data, and training data consists of many attributes. These attributes, name, rank, years, tenure, this only we are calling it as attribute. And generally the last in the classification process or supervised learning process, the last column represents the class label. This is the class label. So based on this only the model is trained. That is trained, and we are constructing a model. So here we are having the training data. So these each and everything are called as records. Mike, Mary, Bill, these are records. This name, rank, years, that we call it as attributes or features. So both the names we can use, attributes and features we can use. Then this training data is applied to a classification algorithm. Say for example, now we are using a decision tree algorithm. So then we are constructing a classifier, that is a model is constructed. Here model is constructed means here a decision tree is constructed. Then we are using the model, we can extract some rules, and we can, using the model, we can classify the data. Suppose if rank equal to professor or years greater than 6, then tenure equal to yes. Likewise, some rules are generated from the decision tree. So using the rules, we can classify the data. Next, using the model in predictions. Here you see we are having the testing data. That also, there also we are having the name, all the features plus the class label is also there. Why we are having the class label in the test data? In order to find out the performance of the constructed model. That is how much accuracy the system is providing. In order to find out the performance, we are having this class label in the test data also. But this is mainly for testing the constructed model. For any unknown data coming in, the output is not known for the unknown data. Just we have to use this model to predict or classify the given data. So here we are having the testing data and the classifier is there. Then if we the unseen data is passed on to the classifier, and it will analyze whatever the rules constructed by the model. Here decision tree, so some rules are constructed from the model, and based on that it will predict or classify Jeff, professor 4. So we are 4 years means 4. Then whether he is tenured or not, based on the model constructed, it is classifying it as yes. Suppose some other years are given or something else is given, then we are classifying it as no. Here in the data you see assistant professor 2, no. Associate professor, mainly here professor role plays a main thing, that is professor means, and some years are there. It is giving us yes. So based on here for test data it is yes. But we have to check the training data, how much years are there for giving a tenured no. Likewise we have to see. These are very small data, so we can easily verify, but while doing the projects and all, we are having large or huge data set. It may contain lakhs and crores of records. So manually it is not possible. So generally we have to construct a model, then we have to apply the test data, then only we can verify it from the model. So based on the training data, a model is constructed, then we are giving the test data to the model and we are classifying it or finding the accuracy of the system or performance of the system. Not only measure we are using, not only accuracy, many performance measures are there. That is false positive rate, error rate, true positive rate, precision, recall, F measure, many performance measures are there. So here accuracy, it is a very simple and in all places for all the applications it is used. So it is given as accuracy here, but many more measures are available. So we can use those measures. So this is the algorithm for decision tree induction. So this is the basic algorithm. Generally the algorithm for decision tree is a greedy algorithm. That is, here there is no backtracking possible. Always we are constructing a top-down recursive divide and conquer manner only we are applying. So here in this decision tree, a tree is constructed in a top-down recursive divide and conquer manner. At start, all the training examples are at root. Then first it is at root. Then attributes, if attributes are categorical, that is if continuous value, they are discretized in advance. If it is continuous, we have to discretize it, or some other methodology we have to use if a continuous value is given. Then examples are partitioned recursively based on selected attributes. Then test attributes are selected on the basis of the heuristic or statistical measure, that is information method gain. That is, here in the decision tree induction, 3 versions of decision tree or induction we are looking into. So those 3 decision tree induction methods are based on different attribute selection measure. One is with respect to the information gain, another one we are using the gain ratio, another one we are using is Gini index. So based on the attribute selection measure, the procedure may varies. So the calculation of the attribute selection measure may vary. Other than that, all the steps are same only, but here we are using some attribute selection measure. Based on that, the name of the decision tree is also varying. In the overview, we have seen that ID3, C4.5, then CART. So based on the attribute selection measure only, the name is varying. Then conditions for stopping partitioning, because we need to construct a tree and in one point of time we have to stop the construction process. So when to construct the decision tree construction process. So here, if all the samples for a given node belongs to the same class, then there are no remaining attributes for further partitioning, that is majority voting is employed for classifying the leaf, then there are no samples left. So in all these 3 cases, we have to stop constructing the model, that is the decision tree. So here for the first attribute selection method we are using is the information gain. For knowing more about information gain, the basic is entropy. That is, this is the term used in the information theory. That is, entropy means it is a measure of uncertainty associated with a random variable. So we are performing, it is a measure of uncertainty, because here everything is uncertain. So based on that only we are constructing. So we need to calculate a value to know what percentage it is uncertain, then we are constructing a model. So here how we are performing the calculation means, for a discrete random variable y taking m distinct values y1 up to ym, h of y, how we are calculating is minus sigma I equal to 1 to m pi log pi. Pi is probability of y equal to yi. That is pi. In the example it will be clear this formula how we are applying. Then interpretation is, if we are having higher entropy value, then we are telling that higher uncertainty is there. And if we are having lower entropy value, then we are telling that lower uncertainty is there. So always higher entropy leads to high uncertainty and lower entropy leads to lower uncertainty. Then we are having another term called conditional entropy, that is h of y given x. Conditional means always a given b. So here also we are having h of y given x, that is sigma x px into h of y given x equal to x. So in the example it will be clear, at that time we can see. So the main attribute selection measure, if we are using the attribute selection measure as ID3, that is iterative dichotomizer. ID means iterative dichotomizer. If you are using information gain, that decision tree constructed using information gain is used in ID3. So here what we are doing is we are selecting the attributes with highest information gain. Okay, highest information gain we have to select. Let Pi be the probability that an arbitrary tuple in D belongs to class Ci. So a tuple D is there that belongs to class Ci. That is the class label estimated by Ci, D given D. Then the expected information. The expected information is the entropy needed to classify a tuple in D. That is info of D. How we are computing info of D? Already we have seen in the entropy case, that is info of D equal to sigma I minus sigma I equal to 1 to m Pi log to Pi. Then information needed after using A to split D into V partitions to classify D. So for each and every attribute, first what we have to do is we have to find out the information gain for the class label. As such we have to consider. Then for each and every attribute also we need to consider. That is info of A of D equal to for each attribute. What do you mean by A here? For each attribute we are constructing. So sigma j equal to 1 to V dj divided by D total into for each class in that particular attribute divided by the total into info of dj. Then what we are doing is we have to compute the information gain by branching on attribute A. That is gain of A equal to info of D minus info A of D. So the class label information gain minus for each and every attribute, that is the gain. So this is the simple decision tree and that is induction process, that is using the attribute selection measure information gain, that is mainly used in ID3. So this is one example how to compute or construct a decision tree. So here you see for this data only we are going to construct a decision tree. Here we are having age, income, student, credit rating, BICE computer. So BICE computer is the class label. Here what are the number of classes we are having? Only 2 classes, yes class as well as no classes there. So here age it is also divided into different categories, that is less than or equal to 30, then 31 to 40, then greater than 43 ranges are there. Then income we are having high, medium and low. Then student no and yes. Credit rating fair, excellent, 2 classes or 2 categories are there. So how we are constructing the information? What do you want to construct? First we have to construct the info of D we have to construct. Then with respect to all the attributes we have to construct. So first we are computing. First we know that class label is BICE computer. So class P, positive class, BICE computer equal to yes. Then class A, negative class, BICE computer equal to no. Then we are computing the info of D, that is I of 9, 5. Why we are calling it as I of 9, 5? Here you count the no value first. 1, 2, 3, 4, 5. 5 is there. 5 no values are there. 5 no values are there. And then how many yes values? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 yes values are there. So why we are giving as I of 9, 5? Totally we are having 9 yes and 5 no values. Info of D is for the class label. To compute the information gain of the class label only, info of D. This is the first step. So first step you have to compute the info of D, that is for the class label. So we are finding for I of 9, 5. 9, 5 means for yes we are having totally 9 yes classes are there and totally 5 no classes are there. So then we are using, what is the total number of records here? 9 plus 5 equal to 14. So what is the formula to compute the information gain? Minus this one 9 divided by 14, that is minus 9 divided by 14. What is 9? The number of S classes divided by total log to 9 by 14 minus Pi log Pi. So here minus 9 by 14 log to 9 by 14 minus again for the no class. This is for the S class, then for the no class minus 5 by 14 log to 5 by 14. If you use the calculator, you can easily get the value, that is we are getting 0.940. Okay, are you able to get now? So info of D equal to I of 9, 5. First we are computing the information gain for the class label. So how many number of classes, that is yes class and no class are available. So we are finding the information gain I of 9, 5. Then we need to know the total number of records. So minus 9 for the S class, minus 9 by 14 log 2 9 by 14 minus 5 by 14 for the no class log 2 5 by 14. So we are getting this value. This is for the class label. Next, what we want to compute is, we want to compute the value for information gain for each and every attribute. Here, what are the features or attributes available? We are having age, then income, then student and credit rating. So, for each and every attribute, we need to compute the information gain. So, first we are going to compute for the age. So in age, how many categories are available here? Here we are having 3 categories, that is less than or equal to 30, 31 to 40 and greater than 40. So for each and everything we need to find out here. That is info of age of D. That is for 5 by 14. You have to count for each and everything. We have to count less than or equal to 30. How many values available? You have to find out less than or equal to 30. 1, 2, then 3, 4, 5. 5 are there. Among these 5, how many positive and negative? 5. 2 positive and 3 negative classes are there. So we have to find out, for this you have to find out I of this 2, 3 you have to find out. So here this is I of 2, 3. Are you able to get it? So then you are doing is 5 by 14. Totally you are having 5 by 14 into I of 2, 3. This is for less than or equal to 30. Less than or equal to 30 case only we are finding this one. 5 by 14. Totally 5. Among the 14 records, 5 belongs to less than or equal to 30. Then we have to find out the information gain of I of 2, 3. I of 2, 3 means 2 positive as well as 3 negative. So again I of 2, 3, the same formula you have to apply here and find out this value. Then 31 to 40, how many positive cases are there? 4 and 0 negative cases are there. Then you have to find out I of 4, 0 also. Then here you are writing 4 by 14 I of 4, 0 plus greater than 40 case. Totally we are having 3 positive as well as 2 negative. So 5 by 14 into I of here 3, 2 you have to find out. So if you are finding this value, you are getting a value of 0.694. Okay, so I think now it is clear. It is for, this part is for less than or equal to 30 and this part is for 31 to 40. Then this part is for greater than 40. So we are getting a value like this. Likewise, you have to find out the information gain for all the attribute, income attribute, student attribute, credit rating, whatever attributes available, for all the attribute you have to find out. Then after computing the information gain for all the attribute, we have to find out the gain. The third step you have to find out. So first is the first step for the class label. For the second step is for each and every attribute, and the third step is for the gain calculation, information gain calculation, that is also gain for age. So how we are computing the gain for age? It is info of D, the class label value, that is 0.940 minus info of the age attribute. So that is 0.694, that is 0.940 minus 0.694, which is equivalent to 0.246. Okay. Likewise, we have to find out the value for all the attributes. Gain of all the attributes you have to find out. In order to find the gain of all the attributes, what we have to do? Before finding out the gain, we have to find out the information gain for each and every attribute. Then you have to subtract the particular information gain with the class labels information gain, and we are getting a value for all. So gain of income is 0.029, gain of student is 0.15, it is hidden, and for credit rating also we are getting a gain value, gain of credit rating. So with this gain value only, we are going to construct the decision tree. In the next slide, we can see that. So this example only we have used, and we have computed the information gain for the class label, then information gain for all the attributes. Then we have constructed the gain, information gain, that is gain equal to information gain minus class label minus the particular attribute. So now we are having the gain of age. See here, we are having the gain value for age, that is age equal to 0.246, then gain of income is 0.029, then gain of student is 0.151, gain of credit rating is 0.048. So among these gains, which attribute is having the highest gain? This age attribute is only having the highest gain, that is 0.246. So this age attribute becomes the split attribute for this decision tree. Now are you get it? That is, whichever the attribute is having the highest information gain value, that attribute becomes the root. That is, it becomes the split attribute. That is, so what is this information gain? It is an attribute selection measure. So which attribute becomes the root of the tree? Which becomes the split attribute? Now we have find out that using ID3 algorithm, whichever attribute is having the highest value of gain, that becomes the split attribute. So here we have given the split attribute as age. Age becomes the split attribute here. So it becomes the root age. And in the age, how many categories are available? 3 categories are available. That is less than or equal to 30, 31 to 40 and greater than 40. Then what you want to do is, here it is hidden, but you have to draw the tables. So this table you need to draw here. Here you have to draw a table except age, whichever is getting less than or equal to 30 value, the value is the income, then a student, then credit rating. This you have to draw a table here for less than or equal to 30. Then for 31 to 40 also you have to draw a table here, that is income, student and credit rating. Then greater than 40 also you have to draw a table like this. Then you have to find out for less than or equal to 30, Bayes computer also you can draw. You can include Bayes computer also you can include, so because based on that only we are again splitting. So if you draw a table like this, for less than or equal to 30 alone, we can see this value, then this value, then this value, then this value. So totally we are having 5 records. Then what you have to do is, with this class label, so we are totally having 3 no's and 2 yes. 3 no class label and 2 yes class label for this less than or equal to 30. So how it is categorized? Based on student or based on credit rating or based on income? You have to check. So first you see no income high, income high, here also high, here also high. For this no, it is medium. So this attribute is not classifying perfectly. Next we are going in for the student category. Here no, then this no, here no, then this yes, it is yes, then this yes, it is yes. Then you check here, it is correctly classifying. Wherever no is coming in the student also it is no. Wherever in the class level yes is coming in the student also we are getting a yes. Then you have to check for the fair credit rating also. Here fair, here excellent. For the no class we are getting different credit rating. So this doesn't become the split attribute, sub-split attribute. So the student is splitted perfectly based on the class label. So here student become the split attribute. For less than or equal to 30, student become the split attribute. Now what are the values for the student? We are having no as well as yes. And for no, what we are getting, the class label is correctly giving us no. And for yes, the class label is correctly giving us yes. So we finish off here because it is predicting correctly. Then for 31 to 40 case. So 31 to 40 case, you have to check 31 to 40. This S value 31 to 40. Here we are having S value. Then 31 to 40 S value and S value. So here there is no split up. All are S value. So directly you can write here as yes. So if age between 31 to 40, definitely they used to buy computer. No need for going in for the further split up. Then if age is greater than 40, then you have to again check how we have checked for the first category. Likewise, we have to check. And if it is splitting correctly in credit rating, we have to draw the decision tree like this, and we have splitted the decision tree like this. So here we have given student as well as credit rating, but income is not included in the decision tree because the income attribute is not splitting perfectly, so that income attribute is not included in the decision tree. So this is the final constructed decision tree using the ID3 algorithm. ID3 is for information gain. The attribute selection measure in ID3 is information gain. So this algorithm constructed a decision tree like this for the given data. So using this data, how we can predict or classify the data? So suppose some unknown data are coming in. At that time, what we can do is we can pass on the values. If age equal to this value and student equal to this and credit rating is this, then we can classify it as yes, no, like that we can classify it. So suppose we are having age greater than or equal to 40 and credit rating equal to excellent, then we are our model will give the classes no. That is, our model is predicting, or if any test data, unknown data is given, our model is giving it as no value. Okay. So this is the general decision tree construction process using information gain. So it is used in the ID3 iterative dichotomizer. The attribute selection measure used is information gain. That information gain is based on the entropy value, that is minus Pi log 2 Pi. So next is computing information gain for continuous valued attributes. So suppose in the table, if any continuous valued is given, say for example in age it is a continuous valued only. So in the table itself it is given as into three categories, that is less than or equal to 30, 31 to 40 and greater than 40. Suppose if it is not given like this, then we have to how to handle that continuous attribute. For that only we are having a methodology here, that is let attribute A be a continuous valid attribute. Say for example age is a continued valid attribute. Now we must determine the best split point for A. So we have to split the best split point for A, because here it is splitted, no, less than or equal to 30. That is the split point. 30 is the split point, less than or equal to 30. Then 31 to 40. 40 is the split point. Then greater than 40. So that 40 is the split point. So 31 to 40 is accommodated in one group. Then greater than 40 is accommodated in another group. So we have to find out the best split point for that particular attribute. So how to find out the best split point is, we have to sort the value of A in increasing order. Then we have to find out the midpoint between each pair of adjacent values as much as possible. So we have to find out the split point, that is AI plus 1 next value divided by 2 is the midpoint between the values of AI and AI plus 1. The point with the minimum expected information requirement for A is selected as the split point for A. Suppose in the given data, if it is not given, you have to apply this methodology. Suppose that is also not possible, means what you have to do is manually you have to split it into different categories, and you have to apply the decision tree process for the given data. Then here how we are splitting is, D1 is the set of tuples in D satisfying A less than or equal to split point, and D2 is the set of tuples in D satisfying A less than or equal to split A greater than split point, A greater than split point. So the split is find out like this using the last sentence. we are splitting it and we are finding the split point. So for any continuous valued attributes also, we can compute the information gain using this methodology. Next attribute selection measure is gain ratio. This gain ratio is used in C4.5. So this information gain measure is biased towards attributes with a large number of values. So only the successor of ID3 is C4.5 was introduced, which uses the gain ratio to overcome the problem, that is normalization to information gain. Here how we are computing the value means, here we are having a split info of D, that is minus sigma j equal to 1 to V dj divided by D into log 2 dj divided by D. Then we are finding the gain ratio. Gain ratio how we are finding? Gain of A divided by this split info of A. So we have to find out the split information for each and every attribute. Here how we are computing for the income, it is given. So totally for income we are having 3 categories, I think so, low, medium and high. So total number of values in this low, medium, high is minus 4 by 14 into log 2 4 by 14 minus 6 by 14 into log 2 6 by 14 minus again for high it is 4. So 4 by 14 into log 4 by 14. So we are getting a value like this. Then gain ratio of income is gain of A. For income attribute, the gain of A is 0.029. Already we computed, divided by whatever the value, split information of gain, that is that value only we are using. The attribute is the maximum gain ratio is selected as the splitting attribute. Here we are computing the gain ratio for all the attribute, and whichever attribute is having the maximum gain ratio, that value only we are making it as a split attribute, and we are constructing the decision tree. In the textbook example is given, you please go through the textbook for this gain ratio also. Next is attribute selection measure using Gini index. This Gini index attribute selection measure is used in classification and regression trees method. So here if a data set D contains examples from n examples, then Gini, n classes, then Gini index, Gini of D is defined as Gini of D equal to 1 minus sigma j equal to 1 to n p to j. Pj is equal p square into j. So how we are computing is, that is pj square, it is minus sigma j equal to 1 to n pj square. So how we are computing, where we are using this Gini index means, in order to construct a binary decision tree, in such cases only we are using the Gini index. So that the gain ratio as well as information gain we can use to construct not only binary value, for all value it will work, but this if you want to construct a binary tree, binary decision tree, then we have to go in for this Gini index. So if a data set D is split into A, split on A into two subsets D1 and D2, then Gini index, Gini of D is defined as Gini A of D for each and every attribute. First we have to find out a Gini index for the class label, then we have to find out the Gini index for each and every attribute. So for finding the Gini index for each and every attribute, this formula we have to apply: D1 divided by D into Gini of D1 plus D2 divided by D into Gini of D2. Then reduction in impurity is delta Gini of A, that is Gini of D minus Gini A of D. The same procedure only, the attribute selection measure alone is varying. So the attribute that provides the smallest Gini split or the largest reduction in impurity is chosen to the split the node. Need to enumerate all possible splitting points for each attribute. So here smallest Gini split is used for splitting the attribute. So whichever attribute is giving smallest Gini split value, that attribute is or the largest reduction in impurity. So delta Gini of A, whichever is getting a larger delta Gini of A, that attribute is used as a split attribute in this Gini index. So example is given. So here D has 9 tuples in Bayes computer, that is yes we have, and 5 in no. So totally we have 9 tuples in Bayes computer equal to yes and 5 in no. So totally we had 14 records, 9 yes and 5 no. So how we are computing the Gini? Gini of D equal to 1 minus 9 by 14 the whole square minus 5 by 14 the whole square. Then for Gini income, low to medium, because here we are suppose the attribute income partitions D into 10 in D1, that is low comma medium, and 4 in D2. Then what we are doing is Gini of income low comma medium of D equal to 10 by 14. So totally we are having 10. So in D1 we are having 10. So 10 divided by 14 Gini of D1 plus 4 in D2. So 4 divided by 14 Gini of D2. So then Gini of D, how to compute, you know. So you have to apply that, and for Gini income belongs to higher D, we are getting the value. Likewise, for Gini of low comma high, we are getting a value as 0.458. Gini of medium comma 5, we are getting a value as 0.450. Thus, the split on low comma medium and high, since it has the lowest Gini index. So, here we are finding whichever is having the lowest Gini index, that becomes the root or split attribute to construct the decision tree. So here we are assuming that all attributes are continuous valid, may need other tools, that is we can use some clustering to get the possible split values also in this, and can be modified for the categorical attributes, this Gini index. So we have discussed 3 attribute selection measure. One is the information gain, another one is the gain ratio, and third one is the Gini index. And information gain is used in ID3 algorithm, then gain ratio, that is iterative dichotomizer, then gain ratio is used in a C4.5. It is a successor of ID3. Then Gini index is used in CART, classification and regression trees. All these models constructs decision tree only. So each and every model is giving a good results, but there may be some disadvantage in all the models. So this information gain model is biased towards multi-valued attributes. So that is the disadvantage of ID3 algorithm, that is information gain attribute selection measure. Then gain ratio, the disadvantage is it tends to prefer unbalanced splits in which one partition is much smaller than the others. And this Gini index is biased to multi-varied valued attributes. It has difficulty when the number of classes is large, and tends to favor tests that result in equal size partitions and put the value in both the partitions. So these are the disadvantages of each and every attribute selection measure. Though all the methods or all the attribute selection measures are giving good results, but they are having these disadvantages also. So I have given one problem to practice, but you have to construct 2 decision trees, one using ID3, that is using information gain, and another one using C4.5, that is gain ratio. Using C4.5 means it is gain ratio. So both the you have to use both the formula, then you have to construct a decision tree, and you have to check whether if you apply both the algorithm, whether you are getting the same decision tree or not. That you have to check. Then based on the constructed decision tree, you have to find out or classify this data, that is refund equal to yes, marital status equal to married, then income equal to 80k, then whether that particular person will cheat or not. So here the class label is cheat. Generally, if it is not mentioned, means also the last column gives the class labels in this supervised learning process. So practice this problem, and if you are having any doubt while practicing this problem, please ask me and inform me. So in this presentation, we have discussed about introduction to the classification, that is 2 categories of learning, supervised learning and unsupervised learning. Then 2-step process of the classification, that is first one is the model construction process, next is usage of the model, then algorithm for decision tree induction, Then brief overview of entropy. This entropy is mainly used in this information gain calculation. So then we have discussed 3 attribute selection measures. One is information gain, that is used in ID3. Another is Gini index, that is used in C4.5. And last attribute selection measure is gain ratio, that is used in classification and regression tree. And I have given one problem with 2 splits. So you please practice that problem. So whatever we have discussed here about this decision tree is available in chapter 8 in data mining concepts and techniques by Kahn and Hamber. You please go through the textbook also to know more details and examples. You please refer the textbook. Thank you.